Hi, my name is Junho Jung, and today I'll be introducing the mathematical proof of electromagnetic wave nature of photons in hydrogen emission spectrum and the theoretical derivation of a Planck constant. We are all familiar with this figure shown here. This electric dipole moment has been used to explain the existence of this portion of electromagnetic spectrum. However, today I'll be presenting to you how dipole radiation can explain the entire electromagnetic spectrum. In my presentation today, I will discuss first how Planck's constant is theoretically derived. Next, how I discovered from the perspective of electromagnetism the existence of circular motion and electron transition method of electron in hydrogen atom. Then provide mathematical proof for my discovery by comparing the difference between quantum mechanics and classical electromagnetism of energy level. Lastly, how I applied my result to the emission of X-ray and gamma ray in the electromagnetic spectrum. We already know there are two types of dipole radiation. One is when amount of charge is changed, and the other is when alternate current is flow. However, I discovered that there are two additional types of dipole radiation caused by oscillation of constant charge. Electric dipole radiation of oscillation and magnetic dipole radiation of oscillation and revolution. The different type of dipole radiation can be divided into two categories, electric and magnetic dipole radiation. For electric dipole radiation, you can see there are two methods. One is when distance is constant, and the another is when electric charge is constant. For magnetic dipole radiation, there are also two methods. One is when alternate currents flow, and another is when constant electric charge is oscillating and revolving. Previously, we were unable to explain why time-dependent electric dipole moment occurs during the oscillation of a revolving electron in hydrogen atom. However, I discovered that when the moving electron in the left figure generates alternate current while revolving at RNOR, as shown in the right figure, it will emit magnetic dipole radiation. For revolving magnetic dipole, the maximum magnetic dipole moment is the value here, and omega NOR is a modified angular frequency combined with the oscillation and revolution. If you calculate the RNOR and omega NOR, we are able to obtain total radiated power. Because this electron is revolving and oscillating, the radius of RNOR shifts. In the case of n equals 1, then it will result in this figure. After that, we can obtain the cross-sectional area of a magnetic dipole moment here. If we calculate the initial current of n equals 1, the maximum value of oscillating magnetic dipole moment is this value shown here. From that, you can see the retarded vector potential here. Then the retarded vector potential in radiation zone, the vector potential and electric and magnetic field here. From those equations, we can obtain total radiated power shown here. Here is what I have discovered. The total radiated power is the same as the energy level of a hydrogen atom per unit time. From this value, we can also obtain the theoretical Planck constant, which has never done before. and the electron emits the total radiated power according to the oscillation number 1 over n square. We are familiar with the principal quantum number, but I also discovered the oscillation number is equal to the principal quantum number. This result of total radiated power shows that if n is bigger than 1, the electron of a hydrogen atom should emit the electromagnetic wave for infinite time without external energy. However, this phenomenon is not observed because electron performs a uniform circular motion when there is no external energy. So, speed of electron is constant. In addition, I also discovered that when the electron of a hydrogen atom oscillates in response to some external energy, it emits energy in the form of an electromagnetic wave to perform a uniform circular motion, which is the most stable condition. This figure shows that the oscillation and evolution of the electron generate electric and magnetic field respectively, because the electron is considered as a charge. This figure shows energy transition of the electron in hydrogen atom. When the lower angular frequency of revolution over 5 states is shifted to high angular frequency over 2 states due to the oscillation decrease of the electron, the wavelengths emitted from total radiated energy per unit time by conservation of energy becomes this value. Therefore, we must represent the new energy level of the hydrogen atom by including radius, oscillation number, and angular frequency of revolution omega nr by external energy. I can mathematically prove my result by comparing the difference between quantum mechanics and the classical electromagnetism of energy level. As you know, there are two emission methods of electromagnetic wave: magnetic dipole radiation of classical electromagnetism and energy transition of quantum mechanics. From that, we can distinguish between magnetic dipole radiation of classical electromagnetism and energy transition of the quantum mechanics under what stability conditions as shown in this figure. We know that quantum mechanics use time-independent wave function instead of oscillation motion in an oscillating and revolving electron, so we can obtain time-independent energy level. However, because classical electromagnetism considers both oscillation and revolution motion of the electron, it used vector potential of function of time to the electron motion, so we can obtain total radiated power. Therefore, these equations show the difference between Schrödinger equation and vector potential. After my initial discovery, I applied my results to the emission of X-ray and gamma-ray by using the same dipole radiation of a constant electric charge to continue the connection throughout the electromagnetic spectrum. This figure shows how dipole radiation of a constant electric charge are emitted. From this reference, the vector potential and total radiated power of the dipole moment can be obtained. Then we can explain all electromagnetic spectra with these dipole radiations as shown in this figure. Therefore, electromagnetic waves are used as a form of releasing oscillation energy held by the charge to return to an equilibrium state when the charge of an electric dipole is oscillated by external energy. If you'd like further discussion, then please visit this website and leave your comment to get the $1 million prize. Thank you very much for your time.